promised, we're going to talk about organolithium reagents and organomagnesium reagents, which we're going to call Grignard. Okay, these are Grignard reagents. All right, so they possess high degree of ionic character for reasons which were described in the last conversation. Remember, the electronegativity of lithium is about 0.9. No, it's about yeah, that's right, 0.9. And the electronegativity of magnesium is about, oh, I don't remember now. What is it, 1.2, something like that? Either way, it's pretty low electronegativity. So this is a very polar bond. This means that you can consider an organolithium compound to be a nucleophile with a lone pair of electrons on a carbon. That's really the take home here, okay? Do that. Write that out when you see those things. When you see a lithium, just get rid of the lithium atom, put the lone pair of electrons on the carbon and a negative charge, and then ask yourself what a nucleophile like that would do. Same thing goes for this over here. That is essentially just a lone pair of electrons on a carbon. So how do we make organolithium compounds? Well, this is magic, and this needs to be memorized. We take an alkyl halide, and we subject it to 2 equivalents of lithium, right? This has to be done in something like hexane. And then we get an organolithium, right? So this is, again, so the example might be CH3Br. If we go 2 equivalents of lithium and hexane, we're going to get CH3Li, right? And this is the same thing as CH3 as a nucleophile. This is magic, okay? So this is what you need to do. You need to memorize that. So we can do bromine, chlorine, same thing. Do you see what's going on here? This is like a carbon with a lone pair of electrons and a negative charge. You can just put a big X through that, right? Then you can predict what this is going to do, okay? Bromine, same thing. This is magic. I mean, it's lovely. Put a big X through that, put a lone pair of electrons right there, negative charge, and we say we're now ready. So this is a reaction that needs to be memorized. Another reaction that needs to be memorized. This is amazing. We can have an sp2 hybridized carbon, lone pair of electrons. Is this green useful, not useful to you? It's not my favorite color. Right? Lone pair of electrons, and all of a sudden this is ready to, well, actually that's not. That's with the iodine. The lithium we get rid of, right? Lone pair of electrons. And we're ready to act as a nucleophile. All right, we can do the same thing. Well, we're preparing organomagnesium compounds in a similar way, except we're not going to do this in hexane. We're going to do it in ethanol, or not ethanol, sorry, diethyl ether, Et2O, right? That's diethyl ether. And we're doing magnesium. And this is a little bit different. This takes your halide and it just intercalates the magnesium in between it, okay? So in order to make a Grignard reagent, what you do is you take an alkyl halide and you treat it in magnesium with in diethyl ether, and it makes this, where this X is the same X as that, okay? All right, so this is how the previous slide shows how you prepare organolithiums. This is how you prepare Grignard reagents. Now let's talk about one more thing about Grignard reagents. The mechanism for, the other thing about Grignard reagents just shows you how this diethyl ether stabilizes it. But I do want to also point out the mechanisms for formation of these two are beyond the scope of this class. Okay, I don't, as your professor, don't have a good understanding of how this works, and it's not important for what we're trying to do in here. Okay, now here's what we, I say one last thing to point out, and then we'll sum this up with the reactions you need to memorize. These are very strong bases, super strong bases. So I told you before, right? It's like putting a lone pair of electrons on the carbon atom. Well, how stable is a carbon with a lone pair of electrons on it? Not very stable at all. How do I know? Because I know that the pKa of, let's say, ethane, right? That pKa is about 50. What? Yes, that means this is not stable at all. Very reactive. So you put this in with anything at all that it can strip a proton off of, and it will. anything at all. It'll take a proton right off of there. So you just have to make sure that you don't have any acids around at all that have a pKa substantially lower than 50, right? So it's just going to kill your reaction. This basically is a no-go. It's just going to kill it, right? You don't want this stuff. It's just junk. So I think you get the point. It's a really strong base. You just got to watch out what you put it with. Here's another implication of that. If you have, if you try to do magnesium, if you try to make a magnesium organomagnesium compound here, well, this is an ionizable hydrogen, right? The pKa's of alcohols are about 16, so it's simply not going to happen. You're just gonna get junk. So this is not a reaction that you simply can't make this here because of that. So it's not useful. But here are, so here's 3 examples of reactions that you do need to know. Reaction 1 to memorize, reaction 2 to memorize, reaction 3 to memorize. You actually had 0.1, 0.2, and 0.3, right? With your to prepare your organolithiums, really just 2 of them. You had Rx to 2 lithiums, right, and hexane to make RLi, right? That was the first one that I asked you to memorize. That's just preparing the lithium reagent. And preparing the magnesium reagent, which I had a similar reaction on a previous slide. But now that you have those, you have to memorize this. You see, there's my Grignard reagent. Here's my Grignard reagent. Treating it with a 3-membered Grignard. You see that? And water. Okay, 2 steps. So these are all 2 steps. Notice that. If you don't do it in 2 steps, you're going to kill it with the water. This water will kill the Grignard reagent. So these have to be in separate steps. All right. So these reactions need to be memorized. You take a carbonyl carbon and you make an alcohol with it, where you introduce a new carbon-carbon bond. That's the new carbon-carbon bond right there. You take this compound and you add you make a new carbon-carbon bond, right? This oxygen is this oxygen here, right? And you take carbon dioxide and you can make a carboxylic acid with it, right? There's your new carbon-carbon bond right there. Okay, so memorize those reactions and be prepared to use them in quizzes and exams. Good luck.